G'day and welcome to this video on applications of the gradient. The reason I put this in is because in more senior mathematics they're starting to bring in a little bit more of this idea of applying maths in particular contexts, and particularly in terms of speed and acceleration and displacement and all those sorts of things. So I just wanted to introduce it to you now, so that I guess you don't get scared by it a little bit later. So in this situation here, we've got this graph here describes a helicopter trip, and on the traditional y-axis or the vertical axis, we've got displacement north in kilometers and time in minutes over here. If you do physics, I feel like you'll get a much better explanation of displacement, but I'm going to try and give it to you from a maths perspective. Essentially, what we're saying is, imagine you've got a point here, and what we can say is if we're going in this direction up here, we'll say that all of these values are positive and therefore all of these values are negative. So displacement is a bit different from distance. Distance doesn't really matter whether it's positive or negative, it just looks at how far from a particular point it is. But displacement kind of takes into account the direction that you're traveling as well. So we're saying that all of those values are positive and those values are negative. That's why you can kind of get a negative displacement. I hope that makes a little bit of sense. So, what have we got in this situation here? We've got a helicopter that starts at a particular point, and I'm not sure where it is, but it looks like 25 minutes, it travels 200 kilometers. So it goes up here somewhere, and then it seems to rest, or at least it doesn't travel any more north between this point here, 25 minutes, and it looks like about 70 minutes. And then from 70 minutes to, about 90 minutes, it seems to travel another 300 kilometers north as well. So it goes something like that. And then it rests, or at least it doesn't travel any further north, north or south. I mean, it could be going east or west at that time. It doesn't really matter. Because we're only looking at north and south. So it stays there for another couple of minutes, and then it starts to go back to the position that it started. Now, I mean, I know that it feels like it's actually moving across over here, but it's not. This is simply the time that's taken. So potentially this helicopter could just be going in a straight line up and down. It might not be, but we don't actually know enough information to know otherwise. So it continues at this point here. There, it starts going back to the origin, or back to its origin, and it gets back there at about 140 minutes. So therefore it goes all the way back like this, and then it actually starts to go negative. And now all that simply means is that it starts to go south, because we're looking at the direction from north, so it goes south at that point there, and then it rests there forever, and it ends up being 200 kilometers south of the original point that it started. Okay, so hopefully that has explained what's going on in this helicopter trip. Now I'm going to answer some of the questions that are involved in this, and some of them I might have already answered, but hopefully you'll understand. Now, A, how many kilometers does the helicopter travel before coming to the first stop? Well, that word stop is a little bit misleading, because I'm not sure if it's entirely stopped there, but at least it's not going any further north or south. So I'll go with that. How many kilometers does it travel? Well, I've already answered that one before. It looks like there's 200 kilometers before it, as it stops. Now, the second question, for how long is the first stop? Well, it looks like, if we're again going with this idea of the stop, it looks like 25 minutes up to 70 minutes. So what's that, about 45 minutes? We'll go with that. It has a rest for 45 minutes. The helicopter reaches its most north point before having a short break, and then travelling back to the starting point. Okay, that's talking about this bit up here, most north point, and then doing that. What is the speed on the return journey? Now this is why I wanted to put this in. What is the speed? The speed is usually worked out by distance over time, and that's what we can use in this case here. Although I'm talking about displacement, that still is a distance here. It's just whether it's positive or negative. So in this case here, we've got it's gone 500 kilometers, and it's taken us, looks like that's 110 minutes and 140 minutes. Okay, so it will be 500 kilometers divided by, what did I say before? Was it 140 minus 110? So distance over time is the way that you work out speed. And this is why I've put this in there. If you look at that, it's actually just the rise over the run. So we've got, the rise of negative 500 and the run of 30. So this one actually equals 500 over 30, which ends up about 16 and 2/3. And this one would be kilometers per minute. Okay, because those are the two things that we've got. Now, I know I did mention that it's negative 500 here. That, if we were going to work out the gradient, that would actually be negative 500. But in terms of speed, it's probably not all that helpful to talk about speed in terms of negative. I know if you go into physics, you'll start to talk about velocity instead of speed, and velocity you can actually have positive or negative. But let's just stick with the maths of the idea at the moment. So this is where we've looked at gradients. Here we've actually worked out that if we get the gradient of between these 2 points, it will actually tell us the speed. So that ends up being 16 and 2/3 kilometers per minute. Does the helicopter travel faster on the first or second leg of the journey when traveling north? Okay, so we're looking at when we're traveling north, between this point and this point and this point and this point. So which one travels faster? Now I guess we can use the same idea as before, because it's the gradient essentially. It's how much does it travel north over a particular time. It looks like here it goes from here to here. It goes 200 meters and 25 minutes. So 200 divided by 25 is 200 kilometers and 25. Whereas here it looks like it goes 300 kilometers up and what's that, 70 to 90, 20 minutes across. So I think even just by inspection, this one here is going to be far quicker than this part over here. So 300 divided by 20 gives us 15 kilometers per minute. So therefore it's the second leg of the journey, which is going to be quicker than the first leg. E, what does the part below the x-axis represent? Well, I've sort of talked about this a little bit. Anything that's below the x-axis, it just means that it's going in the opposite direction than what we're analysing. So in this case, we're analysing the north direction north. So anything that's below the x-axis just means that he's travelling in a southerly direction rather than in a northerly direction. Okay, so I guess the way I could answer that would be travelling south. Excuse my handwriting. F, what was the total distance travelled by the helicopter? Well, that one's going to be a little bit tricky because we have to think carefully about what's happening here. It looks like he's travelled 500 kilometres north, because that's where he gets to. It doesn't matter really about the brakes. And then he's actually travelled 500 kilometres south, to get back to the original spot. And then he's gone a further 200 kilometres south as well. So I would say 500 and 500 and 200 is his total distance that he's travelled. So that ends up being 1,200 kilometres. And what is the average speed of the journey? And I guess what we need to do is also include brakes in this case as well, because we're just looking at the total average. So in that case, I would look at the total distance divided by the total time. So in this case, we've already worked out the total distance, and the total distance was 1,200, and the total time looks to be, it's not very accurate. Let's just say that it chops off at this point here, because I don't actually know what that is there. So the total time is 200 minutes, so therefore it'll be 1,200 divided by 200, which probably isn't all that difficult to work out. So clearly we can see that that is actually 6 kilometers per minute. Okay, So thanks for watching. This video kind of looks at the gradient applications and distance and speed and all of that sort of stuff. And in the next video, I'll have a look at filling up different containers and looking at the rates at which we fill them up. Again, I guess looking at the gradient. So thanks for watching.